Exponents, the rules of exponents. This means that you move the 4 to the bottom. This is a positive exponent, so it's going to be on the top. So it's 4 times 4 times 4. And some of the 4's cancel. End result is that's 1/16. Right? The laws of exponents now, when we have a power to a power, this becomes x to the negative 64th, because a power to a power means that you multiply the exponents. But remember, negative exponents are not simple, so we're going to write that as 1 over x to the 64th. All right, question number 3. The y is to the negative 7, so you just need to move that to the bottom, so it's x squared over y to the 7th. Okay, we need to solve number 21 using the quadratic formula. So I guess I want to know if you remember the quadratic formula. What's the quadratic formula? X equals negative b plus or minus square root b squared minus 4ac over 2a. So we do remember. So this particular one is in standard form. So a is equal to 5, b is equal to 1, and c is equal to negative 2. So let's just substitute these in and simplify it. So I get negative 1 plus or minus the square root of 1 squared, which is 1, minus 4 times 5 times negative 2 over 2 times 5. Well, we have 1 minus, this is a negative 2. It didn't show up there. Yeah, it's 1 squared. So this turns out to be plus. 4 times 5 is 20. 20 times 2 is 40. So it's 1 plus 40. So it's 1 plus or minus the square root of 41 over 10. And that's supposed to be a 1, not a plus sign. No, I need to. You need to know it. There's a song. Has anybody ever searched it on YouTube? There's quite an entertaining song. Maybe we'll do that if we have time. There's quite an entertaining song. So we have 1 plus or minus the square root of 41 over 10. And then we come on to 22. Evaluate this expression for the given value. And so we're going to plug in 8 into x squared. So what we have here is 6 plus 4 times 8 minus 6 to the 3rd power. So we'll pause here for just 8 minus 6 is 2. 2 to the 3rd power, we're using the right order of operations. 2 to the 3rd power is 8, so this is 6 plus 4 times 8. 4 times 8 is the next thing. So that's 32. So 6 plus 32, 38. Okay, so back on. So question 23. Remember, this is like our test. So question 23 is to simplify this. So we're going to factor. 3x plus 2 is simple. So we're going to now factor this one. So we need to factor 15 times 6. What's 15 times 6? Pull out the handy calculator. You don't need a calculator for that? Come on, Malik. So we're looking for factors of 90 that add or subtract to give us 19. 10 and 9 would be the ones that would work. squared plus 10x plus 9x plus 6. And we're going to factor by grouping. So the top we think is factored, but the bottom, let's see, in these two we could do a 5x. So 5x times x, so that's 3x actually, isn't it? 3x plus 2, and then plus 3 times 3x plus 2. And then we have the top as 3x plus 2. We see a lot of 3x plus 2's, don't we? Are you getting the idea that that's going to cancel? Okay. And so, what if you had some trouble factoring this? Could you take some context clues and think about, oh, I want to see if 3x plus 2 kind of factors into that. So what happens here with this one is that when we get it written out, we get 3x plus 2, and I'm kind of running out of room on my paper here. I'll write it down here. 3x plus 2 over 5x plus 3 times 3x plus 2. And what happens is this 3x plus 2 cancels with this 3x plus 2. And so you're left with 1 over 5x plus 3. Okay, so back to our recording, Josh. It says, from the numbers in the given set, tell which ones of these are integers. 14, 14, negative 3, we skipped the square root of 6. What about 8 repeating? It really is. The repeating numbers, oh, I'm sorry, it really isn't. You're right. The repeating numbers, yeah. The square root of 16 is.
Wait, why is 0?
0 is an integer. Melanie? Give me just a second.
But I thought on the list it was like everything from, oh, never mind.
The square root of 16 is though, right? The square root of 16 is 4. Okay. Now, the rational numbers, that's what I was thinking of when I was doing the 8 repeating, the rational numbers. So, which of these are rational numbers? The 6? Not the square root of 8, because that's irrational.
Wait, how? It's 4, right? No.
No. No, the square root of 8 is between 2 and 3. But it's a number that doesn't end.
So the rational number wouldn't be square root of 8, but it would be square root of 8.
Yes. So this is rational, this is rational, this is rational. This one's rational because the square root of 4 is 2. This one's rational, and this one's rational. So the only one that wasn't a rational number in that list was the square root of 8. Yes, but you can write 5 over 6 as a fraction, can't you? So if you can write it as a fraction, it is a rational number. Okay? So don't just turn everything into a decimal. That really only works with the square roots. Natural numbers. Remember, these are the counting ones, right? So this is not a natural number. This is not a natural number. Is 0 a natural number? How did we remember that again? Who remembers what we said? Whole has an O, so 0 is not going to be natural. What about 5 repeating? No. What about the square root of 4? Yes. Okay, so natural numbers. Okay, number 27. Simplify the exponential expression and assume that variables represent non-zero numbers. So in other words, they're saying that x is not going to be 0 because then it would be something Mr. Thailander would throw a desk at you about, right? Because he doesn't like dividing by 0. Okay. So in this one, you have to remember that you're going to do 5x squared times 5x squared times 5x squared over x to the 15th. So 5 times 5 times 5 is 125. And x to the 246. So, remember we're going to subtract the exponents. So 6 minus 15 is 9. So this turns out to be 125 over x to the 9th. So again, our rules of exponents that we're going to take a look at. Okay, so factoring the trinomial. Common factor? No. So we need to actually pull out the old calculator and say 5 times 24. So that's 120. So we're looking for factors of 120 that add or subtract to give me 26. I got a lucky guess earlier. What are factors of 120? 10 and 12? That won't work. What are 4 and 30? Well, no, not really, but because we have plus and plus, we're not going to be able to subtract. We're going to need to add. So while 4 and 30 work for this, it's not going to work for the 26. 6 and 20? Is that going to work? So 5x squared amounts to the 6 squared. So 5x squared plus 20x plus 6x plus 24. And factoring by grouping. Guess and check is a little difficult when you have a leading coefficient like that 5 sitting there. Yes, Ashley?
So, where did you get the 125?
I multiplied 5 times 24. Okay? And that helps me to split up this group. And all this is the same thing. 26 is 20x plus 6x and the 24. Okay? So now I'm going to factor by grouping. 5x comes out of the first two, and it's x squared plus 4. And 6 comes out of the last two, and it's x plus 4. So again, you can see some context clues there. And so we're going to get 5x plus 6 and x plus 4. Okay. So we're going to rationalize in number 29. And you rationalize a monomial simply by multiplying it by the square root of itself. We're multiplying by 1. And so this would then be 1 over, the square root of 29 over 29. And this one is different because it's a binomial on the bottom. So remembering that? So it's times the square root of 13 minus 2 over the square root of 13 minus 2. So we distribute the top and FOIL the bottom. So the square root of 2 times the square root of 13. Remember, you can multiply these when they're not like terms. So that would be the square root of 26. The square root of 2 minus times negative 2 is 2 square roots of 2. The difference is these are both inside. There's an inside and an outside. So you can see, just quickly to recall that. The square root of 13 times the square root of 13 is is 13. The square root of 13 times 2 is 2 square roots of 13. And then it's negative. And then it turns out to be positive here, which is why we picked the one that we picked, the magic one, if you will. And 2 times negative 2 is negative 4. So these middle terms cancel. And we have 13 minus 4 is 9. These are not like terms, and 26 doesn't have a factor that you can pull out of the radical, so we'll leave that as it is. And you have 2 radicals on the top, which is perfectly okay. Shouldn't be a problem for you to have 2 radicals on the top. Okay, this video is too long, so we need to stop it, right?